Hello and welcome. This is Bijan Hushiar.
The purpose of this activity is to use some MAC address related commands on PCs and on Cisco switches. And this topology is made up of two PCs and one Cisco 2960 switch. No configuration has been done on any of these devices. The plan is to assign this IP address with that subnet mask to PC1 and this IPv4 address with that subnet mask to PC2. I've already obtained the MAC address of PC1 and recorded it in here, and I did the same thing for PC2. I'm going to demonstrate how I obtained those MAC addresses first. But before doing that, I have to make a note that PC1 is connected to a switch from its network interface controller card to FA01 of the Cisco switch using a straight-through cable, and PC2 is connected to FA02 of the 2960 switch using a straight-through cable from its network interface controller card. No other configuration is done on these PCs. Let's go ahead and obtain the MAC address of PC2. I'll go to the command prompt and I type ipconfig space /4. If I do that, the MAC address of the PC is going to be displayed. It's going to be called physical address. And this is the MAC address of PC2 for its fast Ethernet controller card, which I have recorded in here. There is another MAC address, and that's related to Bluetooth connection, which we are not going to be concerned about right now. We are only concerned about the physical or MAC address or layer 2 address of the fast Ethernet 0 of the PC2. I did the same thing for PC1 and I recorded its MAC address alongside of it. Let me just go ahead and perform another command on PC2, and that's arp-a, arp space -a, enter. No ARP entry is found. Our cache table of PC2 is empty because no remote device's MAC address has been resolved to its IP address yet. After it is done, it will be recorded in the ARP cache table of the PCs. The same is true for PC1. If I go to the command prompt of it and perform ipconfig all, ipconfig space /all, will display the physical address of it, which is the same as the one that I have recorded in here. And if I perform arp space -a, you'll notice that our cache table of PC1 is also empty. I haven't done any configuration yet. The first thing that I'm going to do is I'm going to configure PC1 with this IP address and that subnet mask. But before doing that, let me make sure that switch doesn't have any configuration or has not recorded any MAC addresses yet. If I go to privilege mode of the switch and perform show MAC address -table, you'll notice that MAC address table of the switch is blank. No device is detected being connected to any of its ports to record the MAC address of that device and associate it with the port that it is attached to. Nothing yet. As far as MAC addresses are concerned, switches have a base MAC address. In order to know what the base MAC address of this particular switch is, we can perform show version. If we do that, as part of the output, the base MAC address of the switch is going to be displayed, which is not useful for the activity that we are doing right now, but it is very useful in spanning three protocol types of activity. Switches also have burned in MAC addresses for their ports. How many ports on switches? This particular switch has 24 fast Ethernets and 2 gigabit Ethernet ports. It has 26 ports. Each one of them has its own burned-in MAC address, BIA. Again, not useful for this activity that we are doing, but for spanning three protocol activities, it's important. So let's go ahead and practice the command that displays the burned-in MAC address of one of the ports of the switch. We pick FA01. So the command is show interface FA01. As part of the output, the burned-in MAC address of that particular port is going to be displayed. One more thing that you have to pay attention to is that none of these MAC addresses that I have written in here or displayed on the switch would match the MAC address of the devices that you use on your own packet tracer, because MAC addresses are unique globally per device, and packet tracer mimic that idea. So far there is no configuration, and we learned how to display the MAC address of PCs, base MAC address of the switch, and burned-in MAC address of any one of the ports of the switch. Now I want to start configuring the PC with the IP address. I go to the click on the PC, select the desktop IP configuration. I type the IP address in here, 192.168.1.1, with the subnet mask of 255.255.255.0/24. As soon as I do that, there will be communication between these two devices, and the switch is going to capture the MAC address of PC1 and associate it with its FA01 in its MAC address table. So switches populate their MAC address table based on source device's MAC address and the port that they are attached to. To go back to the switch and perform the same command, show MAC address dash table, you'll notice that MAC address of PC1 is captured dynamically, associated with the FA01 of the switch. MAC address is populated. Notice that I used show MAC without dash space address dash table. Previously I used show MAC dash address dash table. Both of them are correct commands. On some models one would work, on some models the others. So if you perform one and it doesn't work on your switch, try the other one, it should work. Very well. Let's assign the IP address to PC2, the same process that we use for PC1 with a different IP address, same network, because they are in the same network. As soon as I do that, communication between these two devices occur, and the switch is going to capture the MAC address of NIC of the PC and associated with its FA02 in its MAC address table. Let's see if it has occurred or not. Let's perform show MAC address table again. Here you go. MAC address of PC2 is captured dynamically and associated with FA02. Now we can say that the MAC address table of the switch is populated for this local area network that we have. Therefore, if PC1 wants to send something to PC2, it will send it to switch. Switch will take a look at the destination MAC address included in that frame and send it out and consult its MAC address table and cross-reference that MAC address to the port associated with it and find out this is the port associated with it and send it all of that. We know that for communication to occur, PC1 must include its own IP address, its own MAC address, the IP address of PC2, and the MAC address of PC2. So when the encapsulation occurs on the sender side, which in here would be PC1 because it's going to start communicating with PC2, when the segments get to a network layer of the OSI model, source and destination IP addresses will be added. Then it will be sent down to data link layer to create a frame by adding source and destination MAC addresses. PC1 knows its own MAC address. It knows its own IP address. We give the IP address of PC2 to it because we say ping that IP address. The first thing that it will do, it will check its ARP cache table to see if it has resolved this IP address to any MAC address. Let's examine that, see if it has done that. ARP-A. No, because no communication has occurred. At this point, if we ask PC1 to ping PC2, it will issue an ARP and include this IP address in that ARP and eventually broadcast that message saying that I want to communicate with this IP address. If this is your IP address, send me your MAC address so I can start communicating with you. The PC2 will send it to PC1. Therefore, PC1 is going to put it in its ARP cache table and also put it in the destination MAC address field of the frame and complete the encapsulation and communication starts. Let's go ahead and ping PC2 from PC1. Ping 192.168.1.2. Replies are coming back. Let's examine the ARP cache table. It has captured the MAC address of PC2 and associated with this IP address. If we do that on PC2, it should have done the same thing. R-A. There you go. It has captured PC1's MAC address and has associated with its IP address in our cache table.
Thank you for watching. If you liked the video and you found it informative, please don't forget to recommend it to others who may be interested. Thank you.